Hi, hello, my wonderful students. This is part number 2 of foldable number 2. And for this one, we're still describing the end behaviors of a polynomial function. For this one here, we have y is equal to 50 minus 3x cubed plus 5x squared. Because our highest degree polynomial is not in front, we're going to rewrite this equation first. So we have our y is equal to our negative 3x cubed. I'm just going to cross it out so I know I've used it. Plus 5x squared. Plus 50, but in reality we don't really need to rewrite the rest of them because the only one we're actually going to be using is our first term, so the rest of it doesn't really actually matter. It is when we actually go back and graph it, but just to know the end behaviors, this is what we're going to go off of. And if you guys remember, if we have a negative a and a odd, we go back to our chart here. We have a negative a and it is an odd end power. It's going to start from the up position and go down. So we know this one here is going to start from the up position and then finish down. So this is going to look something like starting from up here, and it's going to do something crazy like this and then go down. I probably won't have as many curves as I put it, but it doesn't really matter. Just got to make sure that we know it's going to start from the up position and finish from the down position. We have this one here, the next one, which is y is equal to 5 plus 2x plus 7x squared plus 5x cubed. Once again, we have to put our highest term, which is our 3 here. So we're going to have our 5x cubed, scratch it out because I used it, plus 7x squared plus 2x plus 5. And once again, we're only going to use this one here. And for this one, we have an a that is positive and an n that is odd. So we're going to go here. We have our a that is positive and our n that is odd. This is going to be a down up. So we're going to go ahead and put our down and up. I think I meant that one to be down, down. Oh no, down and up. Do I have it? Oh, it's down here. Okay, that's fine. All right. So this is going to be our down and up. Okay, so that means this is going to start from the down position, which is here, and it's going to work our way up and then go all the way up. Like I said, this is just an example of what it's going to look like. It's not like for sure this is what the graph looks like. I mean, it possibly could be. I don't actually know without actually putting into a graphic calculator this term here, but I know that because of this, that this is going to start from the down position and it's going to finish in the up position. All right, let's go ahead and move on to the next one. We have y is equal to 6x plus 25 plus 4x to the fourth power minus x. Once again, we're going to rewrite this and put it in our form of the highest polynomial terms first, and we're going to descend from that point on. So we have our 4x to the fourth power. Then we have 6x minus x. So we have our 6x minus x, which is going to give us a positive 5x plus 25. So if we were going to go back and scaffold to the last page, this would be a quartic trinomial because we have 3 terms and it's to the 4th degree. This is also a positive even. So if we go down to our chart, we have a positive even. Instead, it's going to be up and up. So we can go back to this here and we're going to write our up and up. And we can go ahead and show that our graph is actually going to start from the top and go down and then end up back in the top, even though I know this looks like a quadratic, which quartics can look like quadratics as well. So this is going to start from the up position and finish in the up position as well. All right, let's move on to the last one here for this foldable, which is our y is equal to 20 minus 5x to the 6th power plus 3x minus 11x cubed. So we're going to go ahead and rewrite this here with 5x to the 6th power. Oh, negative, because the negative here follows the 5x. Negative 11x cubed would be the next one in line, plus 3x plus 20 would be our last two. So this is a sextic problem. Sextic polynomial would be what we're looking at, but here we have a negative a and we have an even n. So with a negative a and an even n, we have a down and down problem. So we can go ahead and show this would be a down and down function when we look at it when we're graphing. So this is going to start from the down position and do some crazy stuff like this and then go back down. Like I said, once again, I don't actually know what the graph looks like, so I'm just kind of guesstimating what it would be. But I do know that it is going to both be going down because this is a down, negative a, even n exponential value. And once again, I wanted to show you guys the back part. So this one was an up, down, and then a down, up. So I have an up, down, then a down, up. The next one was an up and up, and then a down, down. So it's up and down, down.